That'll All right, yesterday we talked about the unit circle, and I think we got everything filled in, all the degrees filled in, any place that there was a degree along the circle, we got that filled in already. We got the coordinates, all the x's and the y's filled in. We named the quadrants, quadrant 1, 2, 3, and 4. Yes?
Yeah.
What's the matter?
You didn't get the lines in pieces.
So we didn't get
Like the pie.
like that.
Yeah.
And we're going to talk about that today.
Okay, Radians.
Yes, the radian measures. We did not get them yesterday. All right, so yes.
How come yesterday you used grape, but today you used blueberry?
Oh, I don't know. Let me ask you this. Okay, first of all, you guys understand that along this circle, there's an infinite number of degrees.
Word.
Yes?
Word.
Because you can have 1 degree, you can have 2 degrees, you can have 3 degrees, you can have 22 and a half degrees, you can have 179.000000001 degrees. But the ones that are listed around here are just like the popular angles, the ones that are most common, the angles that you're going to need to be just comfortable with, okay? I mean, obviously you couldn't come up with the coordinates for every single infinite number of angles around the circle. All right, let me ask you this. How do you find the x value at 45 degrees? What do you do? How do you find the x value at 45 degrees? So here's 45 degrees. Here's 45. Oh my gosh. Here's 45 degrees. How do you find the x value there?
Cosine.
Thank you. You do the cosine of
Nice job.
45 degrees. Nice job, Ricardo. Okay.
Thank you.
You do the cosine of 45 degrees, and you get this crazy decimal. What is the crazy? Does anybody remember the value, the decimal value of it?
6.86.
No.
0.707.
0.707, which is equivalent to the square root of 2 over 2. All right, so what about this? We are down here now in quadrant 3. How do you find the cosine value of this one right here, which I believe was 200, I'm putting that in the wrong blank, 225 degrees. What is the y value there?
Sine.
It is the sine of what?
225.
Sine of 225 degrees. And, okay, and it's going to be negative. Why is it negative there?
It's in that quadrant.
It's in that quadrant. In quadrant 3, both the x's and the y values are negative. So this point right here at 225 degrees, which is that point right there, you just have to remember that this is the origin. This is the center of where the x and the y-axis meet. So that means you're going over this far, which is a negative direction, and then you are going down this far, which is also a negative direction. Are you with me?
Yes.
That's why they're both. So both the cosine and the sine are going to be a negative value. All right. What we're going to do today is talk about what about the radian measures, and most of that should be
Review.
review. Yes, thank you for the word. Most of that should be review because we did it last year. So, by the way, when you've been calculating these things, you had to make sure that your calculator was in degree mode. Now what you're going to need to do is make sure that your calculators are in radian mode, okay? So if I'm asking you to calculate the cosine of 5 pi over 6, and your calculator set in degree mode, you're not going to get the right answer, all right?
Okay.
So you need to make sure that if you're using pi's, let me say this. If you are calculating the sine or the cosine of some number that doesn't have a degree symbol with it, you assume it is radian measure. Did you hear what I just said?
Radian measure. If there's not, just repeat that.
I should repeat that.
What degree
Okay,
of
listen.
radian?
If you are finding the sine or the cosine of an angle or of a number and it does not have a degree symbol with it, you assume it is a radian. there has to be a degree symbol. Do you understand what I mean by a degree symbol?
Little circle on
That
top.
little circle, this little thing right here, those symbols have to show up
Got
in order for you to know your calculator should be in degree mode, okay?
Yeah. Yeah.
Let's talk about radian measures. So I am going to switch here for a second to this. A radian measure, first of all, you're going to need your notes out. And this is all stuff that is showing up in section 4.1. So if you could just label your notes 4.1. And we're going to talk about degrees to radians. And I'm just going to do this. So what I'm going to do is show you how to flip back and forth. How do you change something that is a degree to a radian, and how do you change it from a radian to a degree? Yes.
Can I put this on the back?
Sure. Yeah, you can.
No, never mind.
Well, the thing is I'm going to let you use those unit circles on your test, and this is something that I won't be letting you use on the test. You're going to have to remember how to do that. Should that make sense?
Yes.
I am not going to let you use this conversion on your
Why
test,
can't I
but
just
you.
go in the calculator and put it from degree to radian?
I think you're maybe missing the point.
All right, we'll see.
Okay, let me show you.
No, I know that.
If you have to change something, let's start with degrees to radian. If you have a degree measure and you are going to change it to a radian, this is what you need to do. You take the degree, whatever the degree measure is, and you multiply it by pi over 180 degrees.
I remember.
Let us use these
I
last
remember
years.
y'all know how to
Last year.
Yeah, no.
This
I
is
was
this year.
Oh.
So,
You multiply it by pi over 180 degrees. And the reason you can do this is because
me too.
pi and 180 degrees, what do they mean?
3.4.
The same thing.
Oh.
Pi and 180 degrees are the exact same spot on the unit circle.
So I can't.
So if you have the degree measure and you are going to change it to a radian, you take your degree and you multiply it by pi divided by 180. So let me give you an example of that. So you have, let's say, you are at 60 degrees. 60 degrees, you want to change it to a radian. What is the equivalent radian measure of 60 degrees? You're going to multiply by pi over 180. Now this was always confusing to some students last year, was they would go, okay, well that means 60 times pi, so they would go 60 times 3.14. They would divide the answer by 180. But typically when you change things to a radian measure, you want to leave the pi in your answer. So that means you just ignore this for a moment. All you need to do is deal with the 60 and the 180. Well, 60 degrees really means 60 over 1. I hope you would agree with that.
Yeah.
So really all you're doing is taking 60 times pi, which we're not going to deal with right now, and we're going to divide it by 1 times 180. So really all you are doing is taking 60 and dividing it by 180. So do that. What is, and it doesn't matter what mode you are in, if you are in degree or radian measure, when you are just doing a basic division problem like this, what is 60 divided by 180? It's 0.333333, but what do we say?
1/3.
1/3. We say 1/3. So 60 is the same thing as 1/3. You gotta put your pi next to it. 1/3 of a pi. But we don't write it like this. This is awkward notation. It's not wrong. If you wrote it like this, I would certainly accept it, but you won't see it like this. You will see it as pi over 3 instead. 1/3 of a pi is the same thing as pi over 3. Let's do another example. I wanted to show you one more. Let's say that you are at 200.
27.
Let's do 225 again. 225 degrees. And we need to change that to a radian measure. So what do we multiply it by to change it to a radian measure?
Pi over
pi over 180. So we're going to take the 225 degrees and we're going to multiply it by pi over 180 degrees. Remember, you ignore the pi just for a moment. You just take the 225 degrees, you divide it by 180, you do your math enter to reduce the fraction for you. What is 225 divided by 180?
5 over 4.
227.
What is it?
5 over 4.
5 over 4, right, okay. So you end up with 5/4 when you reduce your fraction, but it's 5/4 pi.
So it's 1 and 1/4.
It's 1 1/4 pi. Oh, I'm not going to write it like that though. 5/4 pi is awkward notation. Did you guys remember this from last year? How do you write that?
Isn't that like one rotation?
I just want to know how can I write this a little bit nicer? Instead of 5/4 pi, we write 5 pi over 4. 5 pi over 4 is how you would see it typically in a textbook. 5 pi over 4, which means the same thing. What did you say?
Why was it easier last year?
Agreed.
I swear.
It was, but I don't know why.
All right, let's try this. Let's go backwards. Let's go from a radian. Let's go from a radian to a degree. So we're going to go backwards now. So let's say we have 7 pi over 4. And I need to take that radian. How do I know it's a radian, by the way?
No degree thing.
There's no degree thing. There's a pi, but really it's because there's no degree thing. Okay? Yep, so we have 7 pi over 4. We're going to change it to a degree, and we're going to do that by multiplying. Does anybody remember from last year? What are we going to multiply it by? You're going to multiply it by 180 over pi. And you know what? Let me squeeze this in here. You take your radian, and you multiply it by 180 over pi. 180 over pi. I didn't actually write that out for you. So now an example. Let me label this as an example. 7 pi over 4. Multiply it by 180 over pi. Because what we're really looking for here is to get rid of the pi's. Do you see now how I have a pi on the top and a pi on the bottom?
So we
Pi on top, pi on the bottom. They cancel out.
Goodbye, bye.
What'd you say?
Ooh,
I thought you said
bye.
something.
Say goodbye.
Oh, goodbye, pi.
Goodbye, pie.
All right, so now what we have here is 7 times 180 degrees, and then we have to divide that by 4. So take 7 times 180 degrees. 7 times 180 degrees divided by 4. What'd you get? 315 degrees. So 7 times 180 divided by 4 is 315 degrees. Let's try one more. Let's say that you are starting with, let's do 5 pi over 6. 5 pi over 6. We need to change it so that it is a degree measure. Right now it is not. So we are going to multiply it by 180 over pi. The pi's cancel out. Yes? One on the top, one on the bottom, they cancel out. You take 5 times 180,
You get 900.
and then you divide that by 6.
Right, she said the other
150 degrees. All right, this is what you're going to do today. A little bit of this. Oh gosh. Okay.
Okay, good. Okay.
Do we have
Thank you.
worksheets, or is it going to be like in the book?
Not in the book. No book yet.
Yes.
Okay. Let's say that I give you a situation like this. You're gonna do a little. This is a circle, by the way. Don't laugh at my circle. Actually, you know what? I didn't mean to do that. Let me erase.
You guys have stuff,
I'm
bro?
seeing cheese.
Let's do this. Look, I'm going to give you some problems where you're going to have an x and a y axis. And I'm gonna tell you that
That's a nice Y.
this right here is pi over 4. This angle right here is pi over 4.
45.
45 degrees, yes, it is 45 degrees. But your job is going to be to figure out what is the angle measure from here to here.
Oh.
So you're going to have to do a little bit of thinking here.
Well, no, this side's 180.
It's kind of like a puzzle.
Is it?
Wait, 225, my fault. Or 225.
See, 36.
Yeah, right.
Minus 1.
So if this right here is, and by the way, these radian measures, I still look at them and think, gosh, that's confusing. Pi over 4, I mean, this one's easy because pi over 4 is something I memorized, but sometimes you'll get crazy looking radian measures. Change them to a degree, just so that it's not so strange. Change that to a degree right away, 45 degrees. We know that half of the x and the y axis is how many degrees?
180.
180 degrees. So if I were to go from here to here, that would be 180 degrees, or pi. Yeah, it'd be 180 degrees or pi. But then we have to also add in this part right here, which makes up the rest of this quadrant, which has 90 degrees in it. So this little piece right here would be an extra 45 degrees. So you are going to have 180 degrees, and you're going to add on to it 45 degrees, which, as you guys already told me, is 225 degrees. Okay?
Okay.
You feel all right about that?
Yes.
All right, so you're going to have to do some, thinking outside of the box a little bit today to come up with some unknown angle measures.